Good afternoon. It's a sincere pleasure to be here. I don't think there's enough positive things one could say about this place. It's remarkable. So I'm just going to seed something for the end of my talk by saying that everything about this place really embodies something that I'm going to arrive at in my last slide, which is the incredible capacity of the human brain to occupy different time references. What I mean by that is the ability for the brain to be present, so very much focused on events that are happening in and around us, close to us, or at a distance from us physically, but in this kind of sphere of time, the here and now, as well as the ability for our brain to occupy time spheres that are in the past and in the future. And I'm going to talk about a way to actually access those different time reference schemes. I was always taught not to begin a talk with any apology, but I'm going to break that rule because as an academic, there's no chance that you're going to hear the kind of eloquence or succinctness from me that you have from the other speakers. So that's the danger of inviting an academic. To be clear, I'm a professor of neuroscience and neurobiology and ophthalmology at Stanford School of Medicine. I'm not a doctor, so I don't prescribe anything, but Nick was correct. I'm a professor, and I profess many things. And today I'm going to talk about a number of things related to how your brain works. And I'm going to spend about 30 minutes discussing this, or 35, and then I'm going to hope that we can open up for discussion, because I'd really like to answer your questions more than anything else. So my laboratory at Stanford works on two main topics. The first one is neural regeneration repair after injury, primarily in the visual system. So put simply, we're trying to get blind people to see again. It's a very complicated problem because unlike the central nervous system of other animals, the mammalian nervous system, and in particular that of humans, does not readily regenerate to the extent that we can recover vision, people rarely get up and walk out of wheelchairs. The technology is coming, but unfortunately we still have some work to do. And so much of my lab focuses on the restoration of vision problem. The other half of my lab works on fear, stress, and anxiety states. But we're also very interested in how those states of fear, stress, and anxiety can be useful and practical, and how you can leverage them to enhance your well-being as opposed to suffer them and feel diminished well-being. So I'm going to talk about stress and fear, but at the end, I'm going to touch on some tools and practices that allow you to tap into these systems, as well as how those systems relate to time and your perception of time. And you'll hear that as a recurring theme. So if all that was vague and unclear, what I'm really interested in is this question. How does our internal landscape, our feelings, our thoughts, the stuff that goes on inside us, how does that interact with the external landscape to shape and create our conscious experience of life? What we do, what we feel, what we say. Now, neuroscience, of which I've been a student since I was very young, I got into science very young. My father's a scientist. I always wanted to be a scientist, and except for a brief departure where I thought perhaps I'd become a professional athlete, and then the hard truth of discovering that I wasn't going to do that. I got into neuroscience very young and started working in laboratories very young, and that's basically where I've spent my life. So while I'm not an expert in all domains of neuroscience, I'd be happy to talk about other aspects of neuroscience as well in the Q&A, to the extent that I can answer the questions. Neuroscience as a field knows a lot now about how we make sense of the outside world, how we see colors, how we see edges, how we hear sounds, how we isolate a conversation at the so-called cocktail party effect, the ability to isolate a conversation in a sea of noise. These kinds of things, memory. You see the headlines in the New York Times, perhaps if you read Nature or Science or other scientific journals, you see this stuff coming through. Neuroscience knows a lot about that, and mostly we've learned that in the last 10 or 15 years based on an incredible evolution of new technologies to probe the brain. Not so much the human brain, mostly animal brains, but also the human brain. Neuroscience has also studied a lot about internal states, feelings, how our heart rate is governed, how our breathing is governed. What neuroscience hasn't done terribly much yet, and what my lab is trying to do is trying to understand the interface of how perception of the outside world relates to our perception of our inside world and where those meet, literally where they meet, a physical place in the brain, and how we translate that meeting into feeling, thought, and action. Because we don't exist in isolation. Even if any of us were unfortunate enough to be in a small box for the rest of our lives, your internal landscape is vast, but the external landscape for most of us is vast as well. And we're able somehow, as a species, unlike all other species, to move our conscious experience from our internal to the external and even hold those both in register at the same time. So I'm going to violate a few things that you've heard before. First of all, the idea that you can't multitask is false. It's just false. I don't know where that got started. I think we're feeling very overwhelmed these days with the amount of external information that's coming at us and that's available to us. And our species hasn't really dealt with that incredible buffet. I felt it at the breakfast buffet, kind of overwhelm of delight and excitement and, but so many choices and a limited internal capacity, right? That's a lot of what we feel in a very stressful way. But believe it or not, we can multitask. We can make sense of multiple things at the same time, but not an infinite number of them. How do I know that we can multitask? And how do I know that the number of things that we can pay attention to is 2 and no more? The reason is that we're a primate species, and like all other old world primates, we evolved something called covert attention. Covert attention is my ability or your ability. For instance, I can look at the back of the presentation area here, and I can attend to something here. There's somebody here in my periphery. So I'm looking there, but I'm attending here. That ability of covert attention is something that primates evolved in order to reduce their risk in social settings, because it turns out that one of the worst things you can do in a monkey hierarchy or an ape hierarchy is to look at an ape that's higher up the hierarchy directly in the eyes. That can cost you your life, and that's true for a male or a female. So they develop covert attention. How do you gather information about things without putting yourself at risk? So covert attention is very interesting, and the studies of covert attention tell us that the human brain can pay attention to 2 things. Now, those 2 things can be external, like the back of the room and someone over here, or over there now. I can shift that covert attention. Or it can be my internal world and the external world. Most of the time, we're in touch with our internal world. There are brief states, there are moments where we occupy only perception of the outside world, where we have 2 points of focus in the outside world. But the studies of covert attention tell us that really we are generally paying attention to how we feel internally and to something else externally. I'm going to return to this concept at the end, and I'll give you a tool in which you can exercise it. But to make it just simple, the sphere of your attention is very dynamic. Your sphere can be very compact. So for instance, you could pay attention to just one blade of grass on the lawn or to the entire lawn all at once. You could switch back and forth dynamically very, very fast. So we have the ability to attend to multiple things at once, but not an infinite number. The number is 2. Those 2 things can be outside you, or they can include your internal state and your external state. External real estate, excuse me. Okay. So are we all on board? I tend to have a more sort of a classroom type style here. Okay. If any of this is confusing, please stop me or shout insults or something to halt me. Generally that works. So this is important because we talk a lot about and we hear a lot about where we place our attention in space. But now I'm about to layer an additionally complex idea, but not terribly difficult to comprehend, which is that our attention can be in 2 places, internal and external, or just external. In theory, it could be just internal as well, but not just in space, but in time. So a thought about the past while I look at something in the present, right? An attention to how I feel in the present, but a thought about the future, right? So this is a form of multitasking. It's just not typically the one that we hear about, because typically, the idea that multitasking is a harsh force on us is generally something we hear a lot because it's true. But what I'd like for all of you to be able to do, and what I think one of the most important human powers is to dynamically and deliberately control where you place your attention in space and in time. This is our gift from Mother Nature. Dogs, rats, rabbits, goats, horses, they don't do this deliberately. They have a couple attentional spaces that they can occupy, but they do not make plans. If they make plans, and I'm wrong, they don't execute those plans. And if they do execute those plans, they don't execute them well, because we're the curators of the earth, they are not. We're the technology builders, they are not. They have technologies, but we are the ones that are at the front edge or the leading edge of where things are going, because we have this ability to create plans. I'm going to return to all these ideas at the end, but I want to kind of seed your conscious and your subconscious with that as I move forward. This is what my world looks like, and it's about as interesting as the slides look. It's filled with hardware. But really, science is the practice of things like genetics, molecular biology, chemistry, imaging, crystallography. We pride ourselves on ultra-controlled studies, regulatory agencies, big pharma, and deep public trust, although I suppose there's some lack of public trust when you hear about things like the opioid crisis and whatnot. But generally, most people have deep trust in this process. I certainly do. I'm not saying it's perfect, but I think it's very well intentioned. It's at least the world that I've invested my professional life in. What's good about it? Generally, we pride ourselves on facts, not opinions, although sometimes we get things wrong. The first thing any good scientist learns is that it's okay to be wrong for the right reasons, meaning you didn't have the tools or you were just wrong. We're not very trendy. We don't tend to pick the problems often even that people care the most about, because we understand that there's a series of successive layers that have to be built up before important discoveries can be applied. This is the rule of science. Cell biology had 100 years of basic discovery where no one thought it was going to be interesting for anything, and then cancer treatments are based on much of what we know about cell biology nowadays. Neuroscience is now approaching the time, I believe, this is my opinion, where what we've learned about neuroscience is applicable, and we really start putting it to work. But it's just the beginning, which is exciting. It's excruciatingly slow. And it motivates a lot of what you'll see in the next slide, which frankly are practices that have been carried out for thousands of years, so you didn't need science to motivate any other streams of discovery. But we heard about some of them this morning. And then we've got this field, which I don't know what to call it yet, because you hear it: wellness, biohacking, alternative and holistic medicine, performance optimization, and there are many other names as well. I don't have a bias for or against. I've just decided to invest my professional life in the science side of things. But I certainly delve into this regime as well, and I've spent about the last decade, really my whole life, exploring and trying to find the protocols and logic that exist in this sphere. Also, we have things like meditation. In fact, that's a meditation center at Stanford, one of the only cell-free zones, cell phone-free zones. It's about as big as this stage on the entire campus. You find medical students and other students there. Sigmund Freud, I realize there are problems with some of his theory and behaviors, but to me is one of the great geniuses of the mind, and at least generating hypotheses about the mind. There are many others, of course. The yogic traditions, my friend Wim Hof, the so-called Iceman, people who are using pure physiology to try and push into spaces that are unusual. Cold exposure and breath work is one that Wim has put to intense use and that many people have adopted. I'll talk a little bit about breathing. Things like the chakras, plant medicines, prescription drugs, supplements. It's a vast and important space, and it's one that's really picking up force and that science and medicine, including myself, are really starting to pay more attention to. What's good about it? It's actionable. You can start today. No one needs to approve anything. It's your life, and you can do what you want. It's generally accessible. I don't have a problem sharing my opinions as long as I label them as such. One of the problems often is that a lot of stuff in this sphere has naming that doesn't let you really understand what it is and really understand how it's different from some of the other so-named things. And that's a problem. One of the things I like about science, hard science, if you will, is that it has names in which we call them operational definitions. So two people on different corners of the planet know whether or not we're doing something same or different. And it does tend to accelerate evolution of tools. Not development of tools, but it's very handy to know that we're talking about the same thing. We're not having an argument about two different fact sets. So that's a kind of issue here, and I think that's a lot of it is because this stuff is delivered in the form of that often the protocols aren't revealed. And so there's generally a lack of specificity in terms of mechanism. So practices are designed to shift your well-being in general, but not necessarily in a specific direction, which is not to say that they're bad. I happen to take probiotics and fish oil I'm very interested in, although I haven't pursued some of the longevity tools that were discussed this morning along the NAD pathway, but I think they're very interesting. So specificity is starting to emerge, but that's just recent. And they're very shrouded. I'm grateful for the other talks that are revealing some of the mechanism and tools and practices, but very often you can find out what you, quote unquote, should do or could do without really understanding what the underlying mechanisms are. And the reason mechanism is important is because mechanism allows you to evolve better tools. Let's be honest. I, nor you, nor anyone has all the tools yet, or else we wouldn't necessarily be here, although I'd still be here for the spa, no matter what. So the fact of the matter is that we need tools, and we need the tools to evolve. So a lot of what my lab has been doing is to take a neuroscience lens on some of these practices and to try and evolve the tools based on understanding of the physiology. So my window into things, and the one that I'll provide you, is a purely neuroscience-based window into these things, but I'm not disparaging of the other routes of inquiry. That's just the route that I've chosen to take. For better or for worse, your entire life, from the time you enter the world until the time you leave, consists of 5 things, and 5 only. I always invite a 6th, but no one, I've never, please, if anyone has a 6th, please let me know. We have our sensations. So if I tell you, think about the contact of your feet with whatever surface they're on right now, that's a perceptual experience, but you were sensing that all along. So your sensory organs, your eyes and your skin and your ears, they're sensing sound waves and touch and photons of light energy all the time, but it's your power of perception that allows you to direct your attention to those sensations. So you have sensations, you have perceptions. Perceptions are which sensations you place your attention on. Those are your perceptions. Then you have emotions, sometimes called feelings, but I call them emotions because feelings can be confused with sensations, especially as you get across languages. So sensations, perceptions, we have emotions. Very hard to understand the neuroscience of emotions. We're not quite at the place yet where we can really understand, for instance, how your notion of happiness is similar or different to my notion of happiness. We're just not quite there yet. Thoughts, which is this somewhat complicated idea of deliberate placing of attention matched with memory and context. So it gets a little more complex. And then we have actions, which are very simple to measure. Behavior is easy to measure. These 5 things are actually powerful to understand. I have a feeling someone has a 6th to offer. So in one moment, I'll take the question. They're powerful to understand because at any moment, you can place your attention, you can decide to place your conscious experience more so on action, on sensation, on thought, or on emotion. And of course, they work in parallel as well. There was a question, or at least a hand went up. Intuition is an interesting one. Intuition, to the neuroscientist, intuition is a combination of sensing your internal state. I'm sorry, I can't hear, and trust in your gut. So I'm glad you mentioned gut. So there is a property of the nervous system called interoception, which is our ability to sense the sensations of our inner organs. But it is sensation. It's just sensation of your inner organs as opposed to your surface organs. So it's to the neuroscientist, it still falls under the category of sensation. And if you match it with memory, like the feeling of déjà vu is a very familiar one to some people, right? No pun intended. The idea would be that you would see somebody or something and sense something in your body that called a recollection. The smell system, for instance, is very deeply routed into the memory system. And because we evolved from a non-seeing organisms that sensed most things by chemicals and odorants in the environment. And so imagine if we were all sightless, navigating into an environment. How would you know who to mate with, who to fight with, who to huddle with for warmth, who was an enemy, who was a friend? It would all be by chemical sensing. So those interoceptive apparati, the machinery, are there. We just tend to rely on it less. Yeah. Last night there was a group of us lost trying to go to the party, and we started navigating by sound. And even that was a little bit challenging, right? We're so visually driven. Human beings, more than any other species, are so visually driven. I'm not going to get into the gender biology of these 5 things. That's a separate discussion, but one that's quite interesting, of course. Okay, so let's start talking about stress. What I've tried to do is give you a palette of understanding of some of the ways that I view your life experience and my life experience. And I want to talk about vision in particular. So more than 40% of the human brain is devoted to visual processing in some way or another. It's a remarkably high number. Movement would be the other one that occupies a tremendous amount of neural real estate. We gave up our reliance mainly on olfaction, on smell, in favor of this visual sense. It is extremely difficult to navigate the world and survive as a sightless person. But it's interesting because our eyes actually weren't designed for us to see. Their first job, the very first job that your eyes had, was to set your overall level of what we call internal arousal or stress, how alert you are. How do I know this? Well, your eyes are not actually their own thing. They're actually a piece of your brain. They are an actual bona fide piece of the central nervous system that during the first trimester was squeezed out of the skull and stuck outside of your skull. It's a 3-layered structure in the back of your eye called the neural retina. It's about as thick as a credit card, and it's responsible for everything you see around you. But its first job, the reason that Mother Nature squeezed your 2 little pieces of your brain out of your skull, was to determine how much alertness to have at different times of day. Because as the Earth goes around the sun and it's spinning, Mother Nature wanted to match our activity cycles, at least in humans, to the times in which it was light out. And so you have a category of cells in your eye that don't sense shape or form. In fact, they don't see anything at all, except they tell your brain when the sky is very rich in blue hues, like in the early part of the day, or amber hues in the late part of the day, and they signal a clock that sits right above the roof of your mouth called the suprachiasmatic nucleus. And that clock secretes a peptide, a hormone like protein that tells every organ in your body, your gut, your liver, your heart, your lungs, when to be alert and when to be asleep. It also informs the pineal when to secrete melatonin or not. In fact, light is suppressive for melatonin. So this is why at the far poles, in long days, people tend to have more activity. They tend to breed more, animals as well. And in the dark days of winter, maybe they still breed. Humans aren't so much seasonal breeders. A lot of births in September in the northern hemisphere, so we're not strictly seasonal breeders. But this mechanism of the eyes, or this piece of the brain that we call the eyes, sensing when it's light and when it's dark, was set there primarily to set your internal state of when to be awake and when to be asleep. It's a whole discussion that we could talk about with jet lag and food rhythms, etc. But this is why one of the most basic and important health practices that you can develop is to get some amount of bright light exposure, ideally through sunlight. Never look directly at the sun, of course. If you have a retinal degenerative condition, don't get too much bright light. But assuming healthy vision, bright light in the early hours of the day, even if you wake up before the sunrise, tells your brain, these 2 pieces of your brain we call your eyes, your neural retina, which tells your central clock, which tells every organ in your body how to align its activity. And this is failures to set that system are a major cause of gut issues, of immune issues. In fact, there's been thousands of studies looking at the different health metrics in various treatment regimes, but also just in terms of learning and performance, hormone regulation. It is our kind of primordial and most important form of arousal regulation for the entire body. In fact, every stem cell in your skin and in your hair, every hair follicle has a stem cell, is actually regulated by light to the retina. Getting sun on your skin, whether or not that you decide that's good for you or not, does not regulate the stem cell or the turnover of skin cells and hair cells. Light to your eye is what instructs that turnover. So these two pieces of your brain that sit outside your eye are responsible for setting your internal state of arousal. In fact, when you get light in the morning will dictate when you're going to get sleepy later that night. Ideally, you would get some sunlight in the evening as well, because you have multiple what are called oscillators in this clock that I referred to. But if nothing else, on average, if you miss a day, no big deal, getting that light early in the day is extremely powerful. And I'll point to a case where it doesn't happen. There's a phenomenon called ER psychosis, where because in hospitals you have a lot of overhead fluorescent lights, which also can set this clock, you have a lot of beeping, flashing things. People who spend too much time in the hospital that become disjointed from these cycles actually go into a form of psychosis. They get home and they get better. So this is the primordial form of stress regulation. And so to me, stress is not a bad thing. Stress is an adaptive thing. And I'm going to layer into that argument a bit more. Here are two vastly different visual worlds. The visual world of a predator, like a fox, and the visual world of a grazer, like a cow or a sheep or a goat. Cows, sheep, and goats always see the world this way, in panorama, like a globe. They actually don't have the neural apparatus to view detail in specific locations in space. Whereas you and I have both these systems. The fox can see high acuity detail through what's called a vergence eye movement, bringing the eyes together on a common point. The temperaments of these animals are very different. Most grazing animals are very placid. And one of the reasons, not the only reason, but one of the reasons they are so placid is because they only view the world in panorama. Whereas this high acuity vision system, when we place our vision on a particular location in space outside our body, or even if we focus inward to that interoception that was mentioned earlier, when you place your vision, your consciousness, to a particular focal point, there's an increase in autonomic arousal. It is slightly stressful to focus your attention. So if an animal like this is hunted and killed amidst all its friends grazing, 5 minutes later, they're all grazing again. They're so placid, they can't even stress about it. Whereas humans have this capacity to develop things like post-traumatic stress disorder, etc. Predators like the fox, the lion, and so forth, are very good at toggling back and forth between these states of panoramic vision and focal vision. They know to use focal vision very sparingly because it is very high burn rate, very highly energetically demanding. And when I say energy, I'm referring to something very specific. There's an associated increase in the neurotransmitter norepinephrine, which is just adrenaline, same thing, and some other neuromodulators. So focusing is stressful. The reason hard work is hard is because it was designed to be hard. Those increases in stress that you feel when you focus your attention, like a fox hunting or a lion hunting, are literal increases in epinephrine, in adrenaline in your system. But positive things result from that. You are able to pay attention, and therefore you're able to remember what you're seeing. You're doing very careful calculations. And the calculations, I'm going to refer to this again at the end, are calculations about space, and I don't mean outer space, space and time. What is where and what's happening? The watchmaker, the sniper, the intense conversation with somebody else when you want to run away because it's uncomfortable, but you stay locked in, is stressful because it was designed to anchor your entire focal point of consciousness to what's going on at that location. And the best way that neuroscience, or Mother Nature rather, knows how to do that is to pump adrenaline into your system and to change the way you see the world. So whereas the light from the sun sets this internal arousal of when to be awake and asleep, you also have two other mechanisms that don't have anything to do with what you see, but they absolutely control your level of internal stress. And so the second tool or suggestion that I'll give you is that you practice this. When you're focused on something, whether or not it's your phone or another person, even if you don't register it as high levels of stress, you're using your attentional capacity, and that capacity runs down across the day. Every time you use that, learning to use that deliberately is a very powerful skill. and I'll give you a practice at the end that'll help anchor all this together. The panoramic vision mode is one that in recent years we use far less of. It naturally occurs when you see horizons and you're outside. So if you go out and look at the horizon, your eyes naturally diverge and you go into a kind of panoramic vision where you can try this right now, though. You can look up here at the stage and actually try it while you keep your head and eyes stationary. Try and see people around you and try and see the sky as well, and then actually see yourself in this environment. That is associated with a drop in autonomic arousal. Panoramic vision is the way that all animals, besides humans, unless they deliberately decide to, regulate their level of stress, unless they're asleep. They shut down this vergence eye movement, this focus, throughout most of the day, and they only use it very sparingly because it is intense. Now, we do have tremendous attentional capacities, but knowing that you can actually drop your level of stress by simply going into panoramic vision is something that most people don't know, because we think so much about the capacity of the eyes to see form and shape that we forget that this is actually the fastest and most complete way to drop our level of autonomic arousal or stress. Respiration, which we'll talk about as well, will get you there. But if you want what I call a real-time tool, one where you don't have to run off and do something else to center yourself, but that you can do in real time, that also is covert, no one knows you're doing it, you enter panoramic vision and you drop your stress very quickly. We see this in the laboratory, and it's a well-known phenomenon that the focal vision increases your level of attention and stress. So you have options. You can be calm through panoramic vision, and believe it or not, even though your vision widens, this is the size of your pupil when you're calm. This is the size of your pupil when you're alert. Now, why did Mother Nature put this in, that we would change the way we see the world when we're stressed, when we have a focus or an alertness? This is what trees look like filtered through the optics of a calm state. I didn't make this up. This is actually what the image looks like through the filtered optics of an eye at that calm state. This is what you see when you're stressed. Now, this is great because this is what allows you to focus on your work, and this is what keeps you distracted and has you checking Instagram 6 times a minute. This is focal vision. This is panoramic vision, but this is also this is the state that you can enter when you're very focused. Now, why? So this system of stress was not designed, you don't get one stress system for work and one for your kids, one for focusing and enjoying your work, one for entering flow. And I'm good friends with Jamie Wheel and Stephen Kotler, and I think it was Csikszentmihalyi who first came up with the definition of flow, but we all are chasing these states that seem so wonderful, right? I'm going to be in a state where I'm fully focused, it feels good, everything's in flow, time is kind of there but not there. My approach, at least my laboratory's approach, has been to take the neuroscience as an entry point to try and teach people to teach themselves about the states that they want to occupy. So when you want to be focused, you need to focus your visual system, literally, because the visual system is the primary way that you anchor the rest of your nervous system in space and in time. And I'll return to the time thing in a moment. So panoramic vision, when you're calm, you see the big picture, but you have a harder time focusing on detail. When you're alert and you're quote-unquote stressed, you can see fine detail, but you're missing a lot of what's happening. Your reaction time is much, much faster when you're calm. If you've ever been walking along or bicycling and you close your eyelid and a bee hits your eyelid, and then you realize that a bee hit your eyelid, you didn't consciously see it coming at you, it's because you were biking along in panoramic vision. When you bike or when you drive, provided you're not looking at your cell phone or texting, you are in panoramic vision. You don't need high acuity vision to do that. I'm from Silicon Valley. I was born at Stanford Hospital. I was trained at Stanford. I work at Stanford, probably die at Stanford. I'm from Silicon Valley, and there's a lot of this in my life, looking at the phone. It is not an evil device, but every time that, I'll just use myself as an example, every time I walk between meetings or walk between events and I'm not going into panoramic vision, I'm giving up an old tradition that was wired into our nervous system over tens of thousands of years to go into panoramic vision and to relax the state of my nervous system. And it's no wonder that many of us are finishing out our days kind of more exhausted and depleted. I personally don't think it's just about the information that's coming to us in these devices. I think it's the fact that we're overworking this incredible attentional device, which is these two pieces of our brain sitting outside our skull, by focusing all the time. So another possible tool or practice would be take advantage of Mother Nature's design for stress relief to go into panoramic vision when you have the opportunity to. It's very powerful. It is, without question, the fastest way to downregulate or shift down your stress level in your so-called autonomic nervous system. No other practice will do that as quickly, because no other sensory system has a direct route into this brainstem area that controls arousal. It's called the reticular activating system. And the second cranial nerve, optic nerve 2, is the one that routes directly to that area of the brainstem. Everything else has to go through a series of processing. Your eyes were put outside your skull to control these things. And then, of course, we got all these wonderful things like color vision and form vision and motion vision. But those came later. Those came much later. So your eyes are a tool for regulating your internal arousal state. Now I want to talk about fear. I'm going to talk for about 5-6 more minutes about fear, and then I'm going to touch on some higher level concepts. We study this stuff in the lab 2 ways. This is a mouse in a fairly innocuous setup. I'll tell you right now, you have 3 responses to stress. You can stay stationary, you can move forward, or you can move back. And I'll sort of give you the punchline. The most stressful thing to do is to try and do all 3 at once, or to toggle back and forth between states. And I don't mean that in any psychological sense. A graduate student in my lab did this study where she essentially showed these animals, these overhead looming discs that resemble predators, and they either run to a shelter, that's one response. This is the other response that animals just naturally have. They go into complete freeze mode. Turns out this is the lowest stress mode. Freezing is actually a good response. It gives you options, and you're very undetectable in some cases. You have the opportunity to flee or to stay stationary. And then there's this third option, which Lindsay discovered, a particular brain area that when stimulated, the animals will tail rattle, which is a sign of aggression. It's like, okay, come and get me, because they're actually calling attention to themselves. And they'll continue to do that walking out in front of the threat. We were fascinated by this. It's really Lindsay's discovery of this brain area. But to us, what was even more interesting was that these animals that confront these threats, simply by virtue of the fact that they stay in the presence of the threat and they move forward, physically forward, receive an internal signal, a chemical signal that's incredibly pleasurable. There really is something adaptive to moving forward in the face of threat. And this makes sense evolutionarily why this would be so. That if we all, let's say we all inhibited this place, I don't think there'd be any good reason to leave, but if for some reason there was a reason to leave, we would need to look out into the world and anticipate outcomes, but ultimately we would have to do something about that anticipation. And we would have to move into those unknowns. Mice are great, but they're mice. And so a few years ago, this postdoc, who's actually the one in the movie, Melis Yilmaz, who's Turkish, incidentally, said, I want to study this stuff in humans. And so we developed a fairly elaborate virtual reality environment in our lab to do the exact same thing as we do with the mice. I don't know why programmers don't comb their hair, forgive us. They're here in a box. They can perceive things like heights, where then you can encourage people or force them to drop out into visual environments. That VR is very immersive. It gives people real presence. It's the best thing that we can do to give real life experience in the lab. But these were cartoons, and so we really wanted to create real world experiences that probe fear and address some of these hypotheses in these brain areas. So I'm going to talk about that. But before I do, I want to point out a classic study published in Science in the late 60s, one of 3 studies, where humans had electrodes embedded below their skull and had the opportunity to stimulate in their brain anywhere they wanted. Anywhere they wanted. So there are brain areas that they could stimulate whose names aren't important, where people would feel things like they like it okay, or feel great, or even sexual thoughts, elimination of bad thoughts. The number one area, the area that felt best to people to stimulate, and that was chosen as a stimulation place more than any other, was the central midline nucleus for the aficionados. It's in the midline of the thalamus. Same as those mice that are confronting the threats, same area. And the subjective experience was anger and frustration. Anger and frustration and stress is what allowed our species to evolve by exploring new frontiers, by pushing into unknowns, being challenged by ideas and thoughts. Confusion is literally the attempt at synapses, at connections in the brain, trying new combinations of things to try and learn. And that's the other thing that sets us apart from the other species. We are the only species that has such a long window of so-called neuroplasticity where we can learn our whole lives. The cost is anger and frustration, but it's also rewarded, not just in achieving the thing you want, but one of the things that we are suffering a great deal from is that our species in general doesn't quite know how to handle anger and frustration. We see it either as something that there's too much of and we want to back away from, or for people who have so-called growth mindset, which is really the discovery of my colleague Carol Dweck and others, where we lean hard into effort for outcomes. But really, we have neural circuits that are inside us which were designed to sit in a place of discomfort, knowing that that discomfort is a route to new configurations in our brain, learning, confronting fears, pushing into stress. Okay, so stress unregulated is the problem. So people say, well, it's too much stress, chronic stress, you have immune system issues, etc. Yeah, what we haven't done is learn and teach each other, discover the mechanisms of stress reduction in real time. That's my belief. Makes sense. We come into this world as a little baby, all we know is anxiety, and the relief comes from looking outside us. We don't even know what we need. We scream, we cry, we get a diaper change if we have a good caregiver, or milk. So the stress relief, the first learning rule of stress relief that we ever come into this world with is look to the outside in order to calm yourself. It's just the fundamental rule that we learn. And then, of course, there are now tools and practices being discovered that allow us to adjust our stress level, but not so many that allow us to adjust our stress level in real time as things are happening. So we've moved into very stressful regimes now in our VR protocol. You know, I had to go out into the world and find people that like to lean into stressful circumstances and try and bring those back to the lab. We did consider taking people cage exit diving with great white sharks. This is off the island of Guadalupe, and my good friend Michael Muller swims, we brought him along to film VR, so if you come to my lab and you want to be a subject, we'll pay you. The Muller's going to come over. He wears these yellow things to look like a tuna to get really close to them. He loves this stuff. It's interesting. You can actually do this. I'll just, if nothing else, you can take it. If you ever see a white shark, well, chances are it's not the one that's going to eat you, but there's another one coming for you. But that's not very reassuring. The reason the sharks don't eat you when you do this is if you swim toward them, all animals have a natural looming response. If you move toward them, they back away. So we bring these kinds of experiences to the lab. This is literally the human version of that mouse confronting stress. And I think the reason Muller likes this so much is because it's that same confrontation of stress that you can see with the patient with the electrodes in their head and so forth. So learn to control your stress level in real time, using your visual system as a primary tool, and I'll talk about some visual tools as well. Okay, in the last couple of minutes, I want to talk about space-time representations. We heard a absolutely masterful talk from David White, who's written extensively and has poetry about the relationship between past, present, and future, which I find incredible, and it really highlights a fundamental feature of the human brain, which is that we can not just look inside ourselves or feel inside ourselves, not just look outside ourselves and maybe even have empathy for or sympathy for things outside ourselves. So not just attention in space, but attention in time. So this gets a little bit complicated, but I'm going to try and make it as simple as possible. This is more at the theoretical stage, but I thought it'd be fun to entertain, and you can kind of filter your own real-life experience through this and tell me whether or not it works or not. I get a lot of questions these days about, are there going to be smart drugs? Are there going to be tools that make us smarter? And so we need to really think about human cognition and what it involves. There are a lot of features to human thought and experience, but generally there's a mode of thinking and doing which is strategy building. Let's figure out a way to take the things that we know and put them in an arrangement to accomplish a goal. Maybe you arrange flowers, maybe you're a painter, maybe you're a scientist, maybe you're an entrepreneur. There's strategy implementation. Then you have the strategy in place and it's simply a matter of doing. A lot of human existence was just doing. Placing things where you know they belong to get the outcome that you want. It's a distinct form of cognition, very different. Then there's task switching. The phone rings. You need to tend to something else. And you have to unlock from that regime and move into another regime. So it's a pivot. And then there's creativity, which is, at least the way I define it, which is coming up with new relationships between things in space and time and organizing them in a way that's novel. And then returning, this is the key, returning to the strategy build and implementation. We know many people that exist in the creative regime who never make it back to this regime. In fact, some of the most creative people, the reason that they're sometimes difficult to communicate with, not always, but many of them, is because they sort of exist in this sphere where things are very fluid in space and time. And so if you talk to people who are more on the kind of Asperger's or even autistic end of the spectrum, depending on how severe they are, they're more of the strategy built and implementation, the kind of engineer mindset, right? So humans vary in their bias towards these. Each one is a different space-time representation. So let's go to the extremes. Strategy implementation is taking things that I know where they are and I know where they belong and placing them in a certain place in time and getting an outcome. Creativity involves this kind of fluidity of space and time. I don't even really know where things are coming. You hear things like they geyser up from the subconscious or there's a kind of more global wisdom. You're not going to get to creativity in a mode of strategy implementation, nor are you going to get to a mode of strategy implementation when your brain is locked in a creative mode. Task switching is the pivot, and strategy building is somewhere in between. Now, here's the exciting possibility. Your visual system doesn't just define things in space, it defines it in time. What I mean by that, I'll just start with a simple example, is if I'm just paying attention to my peripersonal space, everything I can control within my reach, there's a certain set of neural networks that are involved that are calculating about this distance. But I can't pick up or manipulate the camera or anything else that's sitting meters away. But the moment I focus my visual attention on it, my brain shifts into a mode where the time domain gets bigger. I know, my brain just knows intuitively that things out there are going to take longer to adjust to. And if you think about us sitting here on this patch of lawn in this beautiful place, but this beautiful place is embedded in a bigger place and a bigger place, and then we're on a planet that's spinning around the sun, you can undergo that kind of expansion in time. Your thought processes and your visual system, depending on how big you bin your visual chunks, defines how big or small you bin your time chunks. This is just the way the brain works because the brain doesn't know what's out there. It just measures space-time relationships. So what does this mean? And how could you access these different states deliberately? We've talked about the use of the visual system to access states of calm or more focus, or to orient yourself in the so-called circadian cycle, the time of day or even time of year as the Earth goes around the sun, simply by changing what you see and when you see it. There's a practice that actually implements these. Every time you sit and you focus your attention on your internal space, and you can do that right now. Typically, I don't lead things like this, but close your eyes for a moment, if you will. Everyone else's eyes will be closed, so you don't have to worry about looking silly. Close your eyes and just try and focus as much of those two spheres of attention on your internal state. Try and bring both of them internal. Your breathing is a good metronome for this process, for anchoring your focus internal, because when your eyes are closed, of course, you can't see anything except what you can sense internal. Okay, now open your eyes. If you look in your peripersonal space, say at the distance of your outstretched arm to your thumb, or if you don't want to do that, you can just look at this space. You're now bringing your brain into a completely different time regime, but one that's designed to execute tasks at about this distance. When you go into panoramic vision, And when you see yourself, keep your head and your eyes stationary, and you're seeing the entire world as a globe and yourself within that globe, and you can expand it to the galaxies if you want, or reduce it to the size of your own existence here in a little tiny pocket on the lawn. That dynamic control, that deliberate control, is indeed a superpower that is unique to humans. No other animal has ever had that power to deliberately place their attention. Creative states occur when something happens here in the middle. This diagram is such that this is one sphere of attention. This is another sphere of attention. If this is you and this is somebody else, great. If you're very focused on what they're saying or they're doing, there's a link between those that I call the tether. You're tethered to that space-time regime. States like sleep, psychedelic states, and states of deep relaxation loosen this tether. If this were a dream, my bulldog Costello could walk on stage and we'd all think that was great, at least in my dream. We could all fly. Space and time become fluid in certain states where the eyes are closed and you're in states of deep relaxation. When you're highly alert or stressed, that tether becomes locked. Your two states of attention that I referred to earlier, the one on you, on your what's going on with you, and what's in your outside world, are locked in place. And you can strategy build and implement very well. Every time your attention drifts someplace else and you lock it back, you're going back to strategy, implementation, and building. Creativity involves allowing that tether, your notions of space and time, to be loose and fluid. This is why a lot of creative ideas come to people on walks, in dreams, and away from task implementation. In the shower, this has been reported for centuries, right? And everyone's got a different story and experience. This is why stepping away from task implementation is often the way in which you can access these new space-time relationships. Your brain continues to work on those while you're in panoramic vision, while you're asleep. And I don't comment, or I don't work on psychedelics, so I don't have much to say about them, except that they are pseudo-sleep-like in that space and time are more dynamic. The tether is loose in some psychedelic states. But sleep and deep relaxation is another. So I decided I would offer tools as I went along. One of the tools that my lab studies is non-sleep deep rest. This is something that I think our society deeply needs. Now there's so much emphasis on sleep and how important it is. We're all going to get dementia if we don't sleep, and now everyone's stressed about sleep. So that didn't work. Sleep is very important, but what about getting better at sleeping? What about learning to go into sensation? I'm personally a big fan of Yoga Nidra, sometimes spelled N-I-D-R-E, sometimes spelled N-I-D-R-A, simply because it's free, accessible, and it teaches your body how to relax. It teaches you, I think there's even something in the Nidra scripts that say, go from thinking and doing to being and feeling. In a neuroscience language and cognition, that means moving away from thought and perception to sensation, just trying to access pure sensation. And not so incidentally, those practices, if you talk to the people who've evolved them over many thousands of years, involve different spheres of time, focusing on the surface of the body, sounds at a distance, sounds in close. So I want to leave you with something, because we touched on a lot. You have two modes of attention. Where you place those modes of attention, or those spheres of attention, I should call them, is critically important. It defines how you are parsing the world in space and in time. And the tether, this link between those two attentional locations, internal and external, or just external, or both internal, can be rigid for task implementation. And you can get better at that by learning how to concentrate your vision at a particular location. Or it can be loose, like going into panoramic vision and allowing new space-time relationships to be accessed by the brain. Happens in sleep, happens in deep rest, also happens when you view horizons or you're simply not focusing on something. Deliberate defocus is a powerful tool for allowing new space-time relationships to arise in the brain. So I've tried to litter my talk with tools as I went along. I'd be happy to talk about more. I threatened 30 minutes and I went an hour, which means if I had said an hour, I would have gone 2. So thank you for your time and attention. I'd be happy to answer any questions.